I'm going to be discussing 3 basic integration formulas. Let me start by writing the integration formulas on the board. Now, I would invite you to start thinking about why these formulas are true. Would you have been able to derive these formulas on your own? If you can see why they're true, then great. You're going to do fine with this topic. Okay? And then one more. So while I'm writing the last formula, remember that integrals correspond to area calculations, and remember that many integrals can be done with a technique involving antiderivatives. Okay, so let's now discuss them each one after the other. Okay, so let's do the first one. Okay, now think about the area that corresponds to the first integral. Would you agree that you basically have a rectangle with a width of 0? All right. The reason you have a width of 0 is because the top and bottom, the limits of integration, as they're called, they're both the same. You have an a and an a. Okay. You can also understand this integral in terms of antiderivatives. Let's define an antiderivative of f as the capital A function. Okay, so the first integral is equal to this blue difference, which is clearly 0. Right? Now think about the areas that correspond to the second formula. All right? So the first area reaches from one side with x equal to a to another side with x equal to b. The second one corresponds to an area that reaches from x equal to b to x equal to c. Okay, let's stop right there. Can you see that those first 2 areas of the second formula are right next to each other and they share a side in common? Specifically the side with x equal to b. Okay, so I think you would agree that if you have two regions, that you can find the sum of the areas by finding the total area. Okay, that's what the right integral is. It's the integral that corresponds to the sum of the areas, the total areas of the 2 areas that correspond to the left side of that equation. Okay? Now, you can understand this one in terms of antiderivatives as well, assuming that the antiderivative works for these integrals. So let me write out what the left side would be equal to. So it's going to involve the sum of 2 differences, because remember, each integral corresponds to a difference with respect to antiderivatives. Okay, I think I got that. Yeah. All right, so now let's think about that left side expression, and you can see that we have some cancellation. Okay, and now let's write out the expression, the difference that corresponds to the right side of the second formula. So that is a of c minus another antiderivative. Okay, and clearly both of those blue expressions are equal. So there's another way to see that that second formula is true. All right, let's now do the last formula. Okay, so I'm going to explain this one in terms of antiderivatives. So the corresponding difference with respect to the left integral is the following. The corresponding difference with respect to the right integral is the following. Actually, that's it's minus 1 times the difference, isn't it? Okay, so you can distribute that minus there on the left side, okay, and of the rightmost expression, and you can see that that has to be equal to the left, the difference that corresponds to the left integral. So therefore, those two blue expressions are equal, and you can hopefully now see why that last formula must be true. All right?